which is the future of ROS by Katherine Scott. This one is pre-recorded because of the time zone.
Hi, I'm Katherine Scott. I'm the developer advocate for an organization called Open Robotics. If you're unfamiliar with Open Robotics, we are the steward organization for a number of open source projects such as ROS, ROS2, Ignition, Gazebo, and one more that I want to talk about today. So if you're unfamiliar with ROS, this is your first time dipping your toe and hearing about ROS, we recommend that you go to ROS.org. ROS.org is our main landing page for the ROS community. There you'll find a bunch of resources to learn about ROS, to point you in the direction of the various sort of community resources that we provide, and just sort of get hooked into the ROS developer community. Recently, we posted a fairly sizable update to ROS.org, including a new explainer video. And this explainer video is geared towards a general audience. So what we've done is we've gone and talked to a bunch of robot developers in the ROS community and outlined what it does, what advantages it provides to them, and how they're using ROS to sort of achieve their goals in robotics. This is, again, a video that's presented at sort of a decision maker level. So if you're trying to introduce ROS to your organization, I highly recommend you check it out. Other than ROS.org, which is your main landing point, we also offer discourse.ros.org. This is our main community discussion forum, and this is a place where you're going to find things like announcements of new ROS packages, ROS events that are happening, new tutorials on various aspects of ROS. All these sorts of things are regularly updated on ROS.org. If you have a specific ROS question, a specific development question that you need answered, we provide answers.ros.org, which is very, very similar to Stack Overflow. And you'll be able to, post your questions on answers.ros.org, and some of the core developers or other people in the ROS community will be able to answer them for you. Finally, we have index.ros.org, which is, if you're a Python developer and familiar with PyPy, is very similar. It's essentially a list of all of the ROS binaries and packages that are distributed for each version of ROS, and you're able to search through it, see if perhaps there is a precompiled package for whatever component that you may be interested in using, say an ouster LiDAR or another component that you'd like to use on your robot. In addition to these resources, we put on a yearly ROS developers conference called ROSCon. We didn't actually have a ROSCon this year. It was all online, so we decided to call it ROS World because we could do it worldwide versus in one location. The event was in mid-November, and we had just 3 days of talks, tutorials, lectures, lightning talks. All of these different things happened at ROS World, and we record them and distribute them for free on the web. If you're interested in learning more about a particular ROS subject, you can basically browse the conference listing, find a talk that's relevant to your interest, and then just watch it. You can find all of that information at roscon.ros.org. So now that I've gotten some of the community resources out of the way, I want to talk about sort of what software releases are going to happen this year and how that process happens. So ROS2 has a yearly release cycle, just like, say, something like Ubuntu. We release a new ROS distro every year. We do this in late May, particularly May 23rd, World Turtle Day, as you can see by our turtle logo. New in ROS2, we have something that's called rolling release, which is just the latest, greatest, whatever the developers are pushing to their master branch that day. We call this version of ROS Rolling Ridley. And so when we make a ROS2 distro or release, what we do is we take that rolling branch, we test it a whole bunch, and then we also pair it with a default RMW. RMW stands for ROS Middleware Layer, and it's the glue code or sort of transport layer code that operates one step below ROS. So what we do is we pick a default, because there's lots of different vendors for lots of different applications. We take that rolling branch and we sort of smash them together and make a release. Those releases are on a yearly cadence, but only every other year do we do what we call an LTS release. Here, LTS stands for long-term support, which is to say, this version we're going to support and update and patch regularly for a certain time period. So for this year's release, Humble Hawksbill, unfortunately we don't have a logo for it just yet, We are going to support that release until 2027. So if you say are looking to start building a new ROS-based product, this is probably the version that you're going to want to use, because you'll have 5 years of support before you do any updating or really think about any new distros. In terms of this process, we are sort of now at the default RMW layer selection phase. And so what has happened back in October is that we've selected the default RMW for the humble release. This process is very involved. We talk to the community, we do a bunch of analytics on the ROS middleware layers underneath ROS, and then we write that all up into a report that's publicly available. So if you're trying to understand this, this particular aspect of ROS development, you can go take a look at this resource, and there's all the information that you could use to make your choice right there. Other than ROS, we also release a simulator for ROS or for other things. Our current simulator is called Ignition Fortress, and just like Humble, this is the LTS release of Ignition. So, and I'll show you a couple demos of what's happened, or what Ignition is good for, and why we think it's such an important part of the robotics ecosystem is having a simulator in a second. I'll show you a couple little demos. Anyway, back in October, we did our release of Ignition Fortress, and there's a ton of huge new features in it. You can see a few of them there, and it's worth checking out. Hopefully here in a couple weeks, we are also going to release the 4th incarnation of our Turtlebot product. So this is every few years we release a Turtlebot, and a Turtlebot is our sort of flagship educational robot and the content that goes with it. This Turtlebot is going to be built by ClearPath. It's got a lot of great features, and I think most notably, it's very similar to probably a lot of the AMRs that you've seen today. And so if you're trying to understand how ROS fits into building an AMR and kind of understanding the code that's necessary and the layers in the stack that make that robot function, you probably should check out a Turtlebot. This year, we're also trying to release just a full simulation version of the Turtlebot that works with Ignition. So on the right there, you'll see just a quick screenshot of the Turtlebot running in this sort of factory setting, and that you can use that to actually learn how the Turtlebot works. You don't need to physically have a robot. We're hoping that the simulation aspect to ROS or this integration of ROS2 and Ignition as an educational platform will really allow people to learn ROS faster and get more in sync with the ROS development process. You can find more about Turtlebot by visiting the link down there at the bottom. So now that I've talked a little bit about the products that we've been releasing for a while, I also want to talk about some of the new stuff that is coming down the development pipeline. And so what we've noticed working with our customers and talking to ROS users is that we're sort of moving past the point where people are just building one robot. And we're moving past the point where people may have a couple of the same kind of robots, and we've moved to the place now where people may have 1, 2, or 3 different fleets of robots operating in one location, and then those robots have to share some sort of resource. That resource may be charging, it could be an elevator, it could be hallways and doors, these tight areas that the robots need to squeeze through. And this problem kept coming up again and again and again. Hey, how do I get all of these different robots to work together in these spaces? And even more importantly, how do I get a bunch of these robots to work together if they don't all run ROS? And so we've been working for a few years now on a new open source project. That open source project is called the Open Robot Middleware Framework. And essentially what this is it's a layer that exists on top of ROS and then can also integrate with other robot vendors, as long as they have some sort of API, like as long as you can control that robot programmatically in some degree, whether it's like start stop or give it waypoints or something more complex than that, you should be able to integrate it into this thing that we're calling OpenRMF and get a bunch of capabilities for multi-robot fleet interactions. So for example, what is OpenRMF good for? And I should point out here that this is All of these are simulations running in Ignition that we've used to test OpenRMF. So OpenRMF has a number of capabilities, one of which is just traffic management. You have all these different robots. They can't all run into each other. You probably want them to conform to the sort of normal human behavior. So say only go on the right side of the hallway, or tell certain robots they shouldn't go in different areas. All of that sort of planning and traffic management is integrated into OpenRMF. On top of that, we've built systems to integrate with physical infrastructure. So we now have robots sharing doors, robots sharing hallways, robots sharing elevators in a particular building, and they're able to do that, and they're able to do that with a degree of like priority. So certain robots may have like precedence in using an elevator. And finally, the other capability inside of OpenRMF is work cell integration. So how do you actually get these different kinds of robots to work together seamlessly to accomplish a particular task? So we don't just do this in simulation. We've actually started taking it out in the field with a few pilot customers. If you visit the link below, you'll be able to read a little bit about our progress using OpenRMF in a hospital setting. So multiple fleets of hospital robots all working together to accomplish a task. And that's incredibly important right now. It's so important, and it's worked out so well, we actually got an RBR Robotics Business Review Award this year for OpenRMF. And you can read all about that at the link below. We're really excited about it. And we're also really excited because it's an open source project for other people to start trying with it, which is what we've seen already. So if you're interested in this sort of thing, please feel free to drop us a line at OpenRobot. You can find out more at openrobotics.org. So thanks. Visit ROS.org, let me know, and have a good webinar.
All right, that's it. That was the last session of today's conference. I hope you enjoyed it, and that you could send in all your questions. If not, you can always contact us afterwards. If you do have any questions regarding the ROS and what Katherine just told us, you can let us know, and we will share that with her, and she will definitely come back to you. If not, I want to thank you. Thank you for your time and your interest, and yeah, hope to see you next time on our next Industrial Technology Conference.